Hello everyone, welcome to the Data Center Academy. On this platform, you will find several data center videos which will definitely enhance your knowledge and understanding about the data center. Myself, Basit Amin, and I am a data center engineer. Today, I'm going to explain in detail data center buildings infrastructure. So let's start from section 1, which is the importance of location. Strategic site analysis. Performing a comprehensive strategic site analysis involves evaluating multiple factors such as demographic presence, accessibility to transport links, and availability of skilled workforce. Bottom line is data center should be where it can meet the business demands and operational requirements. Geographical considerations. Data center should be built where they should have a stable climate and low natural disasters, because in case of climate change, in case of disaster, data center would be badly affected. Proximity to connectivity. Data center, they are always connected with the telecommunication hubs through the fiber cables, so they should be as close to the telecommunication hubs as possible. Risk assessment or natural disasters. Obviously, hazards like earthquakes, floods, hurricanes, or wildfires, they badly affect all the buildings and obviously data center as well. So data centers should be built far away where there is a risk of natural disasters. Potential man-made hazards. Man-made hazards can be tunnels, lakes, flight path, train station, airport, radio frequency towers, etc. etc. All these things, they have a strong negative impact on the data center. So data center should be built far away from man-made hazards as well. Regulatory environment. The regulatory landscape affects data center location decisions, impacting compliance with local laws, zoning regulations, and sustainability mandates. So the bottom line is data centers should meet the country's regulations and laws as well. So let's start our main section 2, which is buildings infrastructure. To build a data center or to convert an existing building into a data center, so there can be many evaluation factors. There can be history of the building, grant by build, whatever you want, power capability, security, floor loading, glass windows, floor levels, building codes, space required, network capabilities, external supply capability, etc. etc. In a data center, in a data center building, it can have several rooms or halls. I have tried to explain those rooms in this one line flow chart. So I'm going to explain each and every room and its function in next slides. And I will explain each and every room or functions in detail in my next lectures as well. So let's start from one line flow chart. The basic purpose is, our main point is the data hall. So we need continual power and cooling to the data hall. For this purpose, obviously we need power from the national grid. So what is a data hall? A data hall is a huge room, or is a hall, or is a space where we place the rack servers. What is a rack server? Rack server is a rack where we put servers inside the rack, and in those servers we put devices, storage devices, where the data is stored in those devices. So the bottom line is, data halls, they have several rack servers, or you can say several servers and storage devices as well. Since those servers, those devices, they emit a lot of heat, so data halls they get warm. So thus there is a need to control temperature and humidity of the data hall. So that monitoring can be 24 by 7, 365 days in a year, all the time they should be monitored. So let's start from our on one line flowchart. This one line flowchart was based on the central point, which is a data hall. So to supply power to the data hall, we need power from the national grid. So national grid, they send, you can say that they send power to the data center in most of the data center, you can say that. So they have medium voltage switch rooms. So incomer from the local grid 1 kV to 35 kV. Average or normally it's 10 kV. So switchboards in MV room to receive power from local grid, and they send it to transformers. Obviously, technically they are step down transformers because we don't need medium voltage for the devices for the for the low voltage switch rooms extra. Mostly two medium voltage switch rooms, one for A supply and one for B supply. It all depends upon the data center redundancy level. I will explain this in my previous lecture and I will explain this in detail in my next lectures as well. So in a medium voltage switch room, we receive medium voltage from national grid, then we send it to the transformers. So in a transformer yard, there can be many transformer. So it all depends upon the data center demand. So it all depends upon the data center IT load. So in a transformer yard, voltage received from the national grid, which is the medium voltage, which is converted into low voltage. So the first thing is medium voltage switch room. Second thing is transformer yard. From transformer yard, that low voltage which is converted, which is average 400 volt. Let's say 400 volt. So 400 voltage, which is a low voltage, that we send that to the low voltage switch rooms. In a low voltage switch room, there can be switches, fuses, breakers, such protectors, power meter, extra. So incomer from transformers and generators and outfit to UPS in UPS. So why UPS? In case of power outage, so UPS would kick in to support the IT load and the mechanical load as well. So there can be another room which is a UPS room where those UPS they can be stored, and obviously UPS they need batteries, so there can be a separate battery rooms. In some data center, or you can say in some small data center, a low voltage switch room, they can have UPS and battery rooms as well. So these three things can be in a same big room or they can be in a different three rooms. Generator room or yard. So in case of any power outage, we don't want the discontinuity to the data, to the server racks, to the data hall. So we need generators. There can be separate designated generator yard for that purpose. Obviously, to run the generator, we need diesel compound. So we need diesel. So there can be a separate diesel compound. Generators, transformers, medium voltage diesel compound, they should be out of the main building because they are the critical. Uh, they are the critical hazards. They are the hazards. So in case of any issue, in case of any fire, they should not reach to the data center or they should not reach to the data hall. Sprinkler and mist system rooms. Well, let's say in case of fire, so there can be several fire suppression technologies. So most of the data center they rely on sprinkler and mist system. So sprinkler and mist system, in a data center, there can be a separate room or hall for sprinkler and mist system, where apart from pumps The water storage tanks can be stored in the same room as well. So fire suppression system bottles room. Obviously, there can be more than one fire suppression system. Let's say first one is sprinkler or mist system. The other can be fire suppression system bottles room. So there can be a separate room for this purpose where the different fire suppression bottles can be stored. I will explain this in detail in my next lecture as well. Holding area. Holding area where goods can be received, unpacked, inspected, and prepared for movement into the staging area. Next is staging area where the goods or equipment can be inspected or configured and safely tested. Service corridor. So, sporting facilities like switchboards, PDUs, DPUs, WDX units, fire suppression bottles, etc., they can be stored and serviced in the service corridor, or they can be stored in separate rooms as well. Meet me room or fiber vault. So where carrier handover point equipment can be expected to run on 24 by 7, where the fibers from outside of the data center and supply connectivity to the data center, from where fiber goes out to another data center or buildings. Security control room, obviously, security should be very tight. I mean, data centers should be highly monitored. Security operations control room or SOC. This room, they have many CCTV cameras, monitoring, so monitoring through CCTV. CCTV cameras covering each and every corner of the building. Facilities control room or network operations control room. So this room to monitor and control building management system, energy management system, ICT equipment, data hall, temperature, humidity, buildings, sporting facilities. So they should be monitored 24 by 7. Dedicated team of shift engineers or shift technicians. So they should be present in facility control room or network operations control room. So they are the first responders to any failure in the facility. So there can be miscellaneous rooms, other data center managers office, client offices, store rooms, chemical rooms, first aid rooms, etc. So last section is future trends in data centers. Data center, so every each and every data center, they are trying to adopt the green data center technology by using renewable energy as much as they can. Innovation and technology, obviously, AI, machine learning, and automation, they are the innovation. So, data center, they are adopting different AI technologies as well. Adaptive reuse of building, instead of building new data center, one can use the existing building and they can amend as per their requirements. So, increasing demand and scalability. So data center should be built like that. If in future there let's say in future, if the owner demands more, you can say more change in the data center, so it has scalability to meet that demand. Global location trends. Global location and global trends indicate a shift handover strategic data center locations in stable, low risk areas with robust infrastructure. Well, I hope you like my video. Please keep watching my data center videos. I will upload many more on my this platform. Please subscribe and share this video on your Facebook, on your YouTube, on your LinkedIn profile as well. Thanks a million for bearing me. Thanks a million for watching this video. And see you in my next video. Thank you so much. Bye bye.